Welcome to The Explainer. Okay, think about the last thing you ordered online. You got an estimated delivery date, didn't you? Well, behind that one simple date is a massive, absolutely critical decision for the company that made your stuff. When exactly did they start working on it? Let's dive in. All right, so let's get right to it. The question, when do we start, sounds so simple, right? But believe me, getting the answer wrong can completely derail your entire operation. So, picture this. You've got an order and it's due in 10 days. What does your gut tell you? Probably start right now, get ahead of schedule. But what if waiting is actually the smarter move? This one choice, this single decision, it actually reveals two totally different ways of thinking about scheduling. And these two philosophies have names: forward scheduling and backward scheduling. Let's break down what they are, and you can see which one feels more, well, you. So first up, we've got forward scheduling. You can think of this as the get it done now approach. The minute an order comes in, you start as soon as humanly possible and you just plan everything forward from that start date to figure out when you'll be done. Let's look at this timeline. It's a perfect, simple example. Process A starts on day 1, takes a day. Then you move to process B, that takes 2 days. And finally, process C takes 1 more day. If you just follow the flow, boom, the product is finished at the end of day 4, way ahead of our 10-day deadline. Easy, right? But on the flip side, there's backward scheduling. This is the whole just-in-time philosophy. Instead of starting immediately, you start with the due date, and you work backward, step by step, to figure out the absolute latest possible moment you can start and still finish on time. Okay, same project, but now we're thinking backward. We start at the end. The product has to be done by day 4. Well, process C takes 1 day, so we have to start it on day 3. And process B takes 2 days, so it needs to start on day 1, which means process A has to be done before day 1 even begins. See that? The start date is the same, but the logic we use to get there is completely opposite. So what we have here is a classic trade-off. With forward scheduling, your machines are always running, everyone's busy, which feels super efficient. The problem? You end up with a huge pile of finished goods, which is basically cash just sitting on a shelf doing nothing. Then you have backward scheduling. It keeps that inventory super low, which is great for cash flow, but you have zero room for error. One tiny delay, one machine breakdown, and you've missed your deadline. But here's where things get really interesting and, a lot more like the real world. Because production lines are rarely that simple. There's almost always a bottleneck. Now, look at this process. Cutting is fast, only 2 minutes. Painting's not bad either, at 3 minutes. But then you see welding, sitting right there in the middle, 5 whole minutes. That's more than double the time of cutting. And that one single slow step, it changes everything. That 5-minute welding step, that is our bottleneck. It's the slowest part of the entire system, and it basically acts like a dam in a river, holding everything back. And this brings us to what is maybe the most important rule in all of production. You really got to get this. It doesn't matter how fast your other machines are. It doesn't matter how hard everyone else works. Your entire system can only move as fast as its slowest part. The bottleneck sets the pace for everyone. And this bottleneck creates total chaos. Before the bottleneck, you get a mountain of half-finished parts just piling up, waiting to be welded. And after the bottleneck, the painting team is just standing around, twiddling their thumbs, waiting for work to slowly trickle through. It's the worst of both worlds. So, if forward scheduling doesn't quite work and backward scheduling has its own problems, what's the answer? Well, this leads us to a much more elegant hybrid solution. The real secret isn't picking one method over the other. The breakthrough is learning how to use both of them together, perfectly synchronized around that one single bottleneck. And here's how that hybrid model works, and it's pretty clever. For every step before the bottleneck, so in our case, cutting, you use backward scheduling. You time it so the parts arrive just in time for the welders, no more pileup. Then for every step after the bottleneck, like painting, you switch to forward scheduling. The second a part is finished with welding, it's immediately sent to the painters. They're never left waiting around. This kind of synchronization is just incredibly powerful. It solves both problems at the exact same time. You slash all that wasteful inventory, and you create the smooth, predictable flow through the whole system. Everybody wins. So after going through all that, how do you actually figure out which strategy is the best one for you? Well, the biggest takeaway here is that there is no one size fits all magic answer. The best method is whatever fits your specific situation. Think of these strategies like tools in a toolbox. The goal isn't to use a hammer for every single job. The goal is to understand what all the tools do, forward, backward, and that hybrid approach, so you can pull out exactly the right one for the problem you're trying to solve.
And that leaves us with one final, really important question. Okay, so you figured out when to start each task to get this beautiful, smooth flow. That's a huge step. But what about how much work you're scheduling? If your perfect schedule has you making 100 widgets on Monday, but only 10 on Tuesday, is your system really balanced? The next big challenge is leveling out that workload. And, well, that's a puzzle for another time.